and in this environment in which the body can rapidly be optimized for productivity.
Not today.
Hello and welcome. If you're a fan of awkward silences and explosive debates, you're in for a treat. Our guest today is someone who can make hydrogen seem as controversial, well, as pineapple on pizza. Tom Baxter is a distinguished member of Hydrogen Science Coalition with a wealth of experience in chemical engineering and critical eye on the realities of hydrogen as a low-carbon fuel. His work often challenges the prevailing narratives, emphasizing a scientific and practical approach to the adoption of hydrogen technologies. Tom's contributions to the discourse of hydrogen's role in achieving net zero emissions are both insightful and provocative, making him one of the leading voices in the field. Tom, welcome.
Thank you.
For the beginning, who is Tom Baxter?
Well, I'm a chemical engineer, as you said. I graduated in 1975 from the University of Strathclyde, and I started my career in petrochemicals. I had a short term, few years in fine chemicals and pigments and additives, and then towards the end of the 1970s, oil and gas was really taking off in the UK. So I joined the British National Oil Corporation as a process engineer, and that experience took me to research and development. It took me to operational support, going offshore on surveys, and particularly I was involved in the development of new oil and gas assets. So the conceptual development and front-end engineering to provide the information packs, the decision packs that would be needed to move from concept and front-end engineering to actually spending money and building the thing. I left oil and gas companies and moved into oil and gas consultancies, and I ended up as a business unit director and technical director of Aberdeen's largest oil and gas consultancy. I had many years there, and towards the end of my career, I started lecturing at university. I helped establish the first new chemical engineering department in the UK in over 20 years, and I felt I had something to offer. I had 40 years of experience to give back to the students, so I started lecturing on a part-time basis, and the other time of the week I was still employed in the industry. So throughout that career, I've been steeped in safety, in technical definition, and costing and economics. And I understand the need for comparative assessments. So we're looking at opportunities. How might we do it? And the key metrics are obviously capital cost, operating cost, schedule, safety, environment. What are your returns going to be? The IRR, the NPV. There may be something about company reputation too, and clearly something about risk, both technical and commercial. So I've got a pretty I would say unusual background in both industrial and academic, and I've married the two of them together. So that's me.
You're well informed from diverse angles.
I like to think so.
Can you elaborate on your main concerns regarding the UK government's enthusiasm for low-carbon hydrogen?
Well, I mentioned the need for comparative analysis. There are options and where we want to get to, and maybe a classic option is hydrogen or electrification. But what I see, I think, and I'm pretty sure it is the case, that it's often silo thinking. The answer is hydrogen. So you put hydrogen in a silo and then you build the case around the silo. You don't look outside the silo at the other options and do a comparative commercial, technical risk assessment of the two options. So silo thinking I think is the biggest concern that I've got.
What are the critical technical and economic challenges you believe are overlooked in the current hydrogen strategies?
I think the challenges are more economic than technical, in the sense that if you think about it, if we're going to make blue hydrogen, that blue hydrogen has got to be more expensive than the natural gas that we made it from.
Yeah.
And if we make green hydrogen, that green hydrogen is going to be more expensive than the electricity that we've made it from. So we're kind of devaluing the source energy that we have by moving it through to hydrogen. So, and in doing so, you're making things more complicated. It's less inherently safe. But the bottom line for me often comes back to is that there's a more commercially attractive option for the consumer than hydrogen.
But when we're talking about ecologic part,
well, so we're talking about lifetime emissions. Is it?
yeah.
Okay. Well, there again, I see I see conflicting information. Of course, if we go the electrification route, immediately the attention is drawn to the minerals, say, that are used in making batteries. And of course, there are minerals used in batteries. There are minerals used in making fuel cells. And again, we have to do the comparison of like for like, and that evidence should support the route, for example, the UK should take. Let's say passenger cars. I see no case whatsoever for hydrogen as an option for a passenger car, a hydrogen fuel cell vehicle. And indeed, a recent government report brought out or analysed the life cycle emissions for diesel car, petrol car, hydrogen, battery, hybrid. And it did it both for a car and a bus. And it was very clear from the conclusions that the overwhelming best option was electrification, batteries. Now, that's not to say batteries don't have issues or electrification doesn't have issues, but as a society, we have to pick the best option or the better option. And sometimes perfect gets in the way of good. We're in an emergency here. We have to move on those options that have a material influence on our greenhouse gas footprint, that the technology is ready now and that we can go for. And I think in surface transport, particularly light vans, cars, urban buses, that nothing speaks to me in favor of hydrogen.
And when we are talking about long distance trucks?
Well, at the moment, I can see the argument for the long distance truck. And remember, we're in the UK in my world, and Scotland particularly, which is actually quite a small country. So the distances travelled in general, yeah, are much more amenable for electrification. But I also look at the long distance HCVs, yeah, and the size of the battery that you might need, and the reasons why people will conclude that hydrogen is perhaps, or a hydrogen derivative is a better solution. But if you look at the scientific or the progress on battery energy density and range and cost, I think the heavy trucking sector, batteries will penetrate there too in the future, and that will become the transport energy of choice will be electrification. And of course, an electric car or bus is at least twice as efficient in terms of converting the core energy, 100 watts, to energy at the wheel. So that means that the electrification route will need half the number of solar or wind stations. So, repeating my conclusion, I think surface transport will almost fully move to electrification, for the reasons that I've given.
And what happens with aviation?
Well, aviation, I think, is an area where hydrogen, not necessarily hydrogen as the element, either in gaseous or liquid form, but hydrogen derivatives could have a role to play. Hydrogen-derived sustainable aviation fuel, and that has big advantages in the sense that we can use the existing engines, the existing designs of aircraft, which must be a huge attraction for those aviation fleets. So yes, yes, aviation is a target, and a proper target, I think, for hydrogen derivatives. And I guess shipping's in the same area, and there I probably see methanol as a hydrogen derivative as one of the keys. But again, I can't see hydrogen as a gas or as a liquid being used to fuel transocean shipping. Biofuels have a great attraction, and again, they're drop-in. So I would see having a big role to play in aviation and shipping. And it might be that we ring fence biofuels for those hard to abate sectors. We don't use biofuels on easy to abate sectors.
How do you view the role of hydrogen in the UK's quest for net zero emissions, especially considering the current technological and infrastructure limitations?
Well, I guess with infrastructure limitations, you're suggesting quite rightly that the network and the electricity grid is choked, or will be choked. Now, what it kind of tells me is that those that push back on me for example, for heat pumps or car electrification, the grid can't take it. And to me, that's an admission is if the grid could take it, they're a better solution than hydrogen. But the reason they're pushing hydrogen is because the grid, not the end use, is the problem. So what screams at me is we have to invest in an electricity grid for the future. That it seems so plain to me, and thankfully, I'm seeing some good initiatives coming forward there, but particularly from the new Labour government in terms of debottlenecking and reinforcing the grid and the networks.
Talking about the heating, how do you assess the feasibility of using hydrogen for heating homes?
Well, it's perfectly feasible, but is it the right thing to do? And let me put a hat on as a potential hydrogen consumer in my house. My two big concerns are how much is this going to cost me, and is it safe? So if I look at the safety, it's clearly less inherently safe than gas, and much inherently less safe than electrification. Compared to natural gas, it's got a much broader flammability range. It's got a much lower ignition energy. It's got a much faster flame speed, which means the intensity of an explosion can be much higher with hydrogen than natural gas. It's also very leaky. Yeah. So keeping it in the pipe can be done, but it's more likely to leak than natural gas. And in itself, hydrogen is a global warming agent. If it does leak, its chemistry interacts with other greenhouse gases and enhances the global warming effect. It also produces NOx, when we burn it. And if we have it in our homes, a fire could be started by a hydrogen leak. But let's say we have a household fire that's not been caused by a leak of hydrogen. But now we have a fire and we have a source of highly flammable gas in the house that if we lose containment in our hydrogen system, will feed that fire and heaven forbid result in an explosion. So anyway, I turn hydrogen from a safety point of view, it doesn't work for me compared with, say, electrification or heat pumps and direct electrification, or indeed even less so than with my heat network. It is inherently less safe. And that's demonstrated by the UK government's work on the safety of hydrogen in a domestic setting. And the program's called High for Heat, the numeral 4, so high for heat. Now, that work showed that that unmoderated hydrogen, so like for like with natural gas in a house, you would be 4 times more likely to get injured with hydrogen in your house than natural gas. And the aim of High for Heat was to make hydrogen as safe as natural gas. So like for like, it's not meeting the aims, the objectives. So to make it like for like, what is proposed is that we put a non-closable vent on in the rooms with hydrogen appliances. So that's basically a hole in your wall. I think 4 inches by 4 inches, and also move your meter outside, and also deploy 2 excess flow valves. Now, the excess flow valves are there that if you do get a leak on the house side of the meter, the excess flow valves experience a higher flow rate. That means a higher differential pressure across them, which will then make the valve seat and close. Yeah. Now, of course, think on a cold Christmas day, we've got our oven on. We've got 4 hobs on cooking our tatties and all the veg. The central heating's on full. It's very cold. The excess flow valve has to pass all that. Yeah. So you imagine the size of the leak that you will need to have the excess flow valve actually closing. So to me it's an admission that hydrogen is much less safe, and the efficacy of the system is questionable. And I just can't see this safety case that High for Heat have produced being a convincing demonstration of the safety of hydrogen. And if you do look at it, what happens when you do deploy the hole in the wall, the excess flow valves, moving the meter outside, the same number of fatalities and injuries can be demonstrated with natural gas. So the conclusion becomes it's just as safe. But if you take a step back, your safety is a combination of 2 aspects. One is the probability of there being a leak, and the second is the consequence of the leak. How big will the fire be? How big will the explosion be? So what the excess flow valve, the meter outside, and the hole in the wall does, it reduces the consequence. So if you do get a fire and explosion, it's not as, let's say, severe or big as natural gas. But then if you look at the other side of the equation, is the probability of a leak occurring. A leak is shown to be 3 times more likely than natural gas, even with the excess flow valves, even with the meter outside, even, well, the hole in the wall won't make any difference. That's there for dissipation. So we're saying, look, we're still 3 times more likely to get a leak and a fire and explosion, but because the bang or the fire is smaller, That makes it safe. That's like somebody selling you a car and telling you this car will crash more often, but because of the safety features, you will be just as safe. Would you buy it? I certainly would. Now, also, if you do look at the numbers and you look at the kitchen um, compared to the rest of the house numbers have shrunk in terms of the fatalities and injuries. But the kitchen numbers have increased. So actually, even with all the precautions, the numbers show you that the kitchen is now a less safe place than it was with natural gas. So I am wholly unconvinced by this work that demonstrates hydrogen is as safe as natural gas. And I've spent a career um, in safety assessments, quantified risk assessments, and it was a quantified risk assessment for domestic hydrogen that I had a long hard look at, and a very good piece of work. I must say that, but I couldn't get behind the conclusions.
I haven't heard better explanation about hydrogen for heating.
Well,
Definitely.
now think on the economics. Yeah. So here we are. We've got it's many millions of families in fuel poverty in the UK, and we're asking them to switch to a fuel that will be more expensive than blue hydrogen or more expensive than electricity or green electricity. How does that work? And what I see is the proponents of hydrogen, particularly the gas network operators, who their lifeblood is having a gas in their networks. So that they're working very hard to convince us that hydrogen is safe in our household. And they also use the phrase affordable. So I've tackled them on the phrase affordable and asked, tell me what the retail price of hydrogen will be. There's a lot on the wholesale prices, but for me as a consumer, I want to know how much is this stuff going to cost me. One CEO of a gas network operator told me it was daft and bonkers to ask that question. And another just gave me a winking emoji and told me he couldn't supply that number. And in fact, that dialogue between myself and those CEOs of vested interest gas network companies made the Wall Street Journal. And boastfully, I think I came out in a lot better light than the vested interest CEOs. So both safety and economics, fuel poverty, I just can't see this case for hydrogen in our houses.
What about hydrogen blending?
Well, that's verging on bonkers as far as I'm concerned. Why? Here we have a very, very valuable low carbon hydrogen. And what do we decide to do with it is blend it probably at 20%. Now that only gives you a 7% carbon saving. Yeah. Why on earth would you do that? Now, if I had green low carbon hydrogen, blue hydrogen, my first port of call would be to use that to displace dirty grey hydrogen that produces 10 kilograms of CO2 for every kilogram of hydrogen that is made. And that's how we currently make it. And we just use the atmosphere as a disposal route for all the carbon. So get after that before blending. It just decimates the value of low carbon hydrogen. And from an energy and mass balance point of view, it makes no sense to me. There's much better things you can be doing with that, well, particularly green hydrogen. If I took that green hydrogen and didn't make hydrogen for the house, but took that green hydrogen to a heat pump, I would need about maybe a third or a quarter of the electrical energy to heat the house than I would if I went through the hydrogen route to heat the house. So again, it plays in how many wind farms and solar stations do we need to heat our houses compared to doing it with electrification. The numbers don't stack up. But of course, if you just look at hydrogen in isolation, You can present a case where blending will reduce the carbon footprint. So isn't that good? But it's not done, and I guess people are beginning a bit weary of me saying, where is the evidence? Where is the comparative evidence? We'll look at it in a silo.
Is this idea still alive in the UK, hydrogen for heating?
Well, as you may well know, and I help on both, there was 3 community trials were being proposed. One at Whitby near Ellesmere Port, and the local residents rejected it.
Yeah.
Expressed their concerns, and that was cancelled by the government. Redcar was cancelled by the government, and the only one left now is Fife, H100, SGN's project in Fife. Now, the area that they've chosen for this trial, this green hydrogen trial, is one of the most deprived areas in Scotland. And they're offering the participants shiny new appliances, £1,000 each, and an assurance on safety. Now, what would you do if you were in fuel poverty and someone, a big reputable FTSE 100 company is telling you, this is safe, we're going to give it to you for the same price as gas, and we're going to give you £1,000 for the duration of the trial? What would you do?
Yeah, that's clear.
It's obvious. Well, I think I know what I would do. Yeah. And
Yeah.
if I'm in fuel poverty and struggling to make ends meet, I don't have time to go and research hydrogen.
Yeah.
I trust what I'm hearing, and that's where it falls down for me. That a lot of the hearing is modified to suit the vested interests in promoting hydrogen. The full story is not given out, and there's a lot of half truths in there as well.
In your opinion, what are the most significant barriers to the successful implementation of carbon capture and storage technologies?
Cost. Now, I worked, well, in my oil and gas career, I worked in many carbon capture projects. We do it all the time in oil and gas, well, particularly in gas treatment. You have to get the CO2 out the gas before you can sell it. Yeah. So again, we used the same technology that most carbon capture options that are built around is a solvent called amine, and that amine captures the carbon, and then we reverse the reaction and release the carbon into the atmosphere, and then we take the amine back, let it capture more carbon, and that is a tried and tested route for carbon capture. So although carbon capture technologies have had a number of issues, I don't have any fears that with a front-end loaded design by competent designers and operating staff, we can't get the surface facilities to work. I think we can. I don't have any real serious misgivings that the surface technology will work. Where I can't really comment, because I'm not a geologist or a petrochemist or subsurface expert. I rely on them to comment on the security of the trap that they're going to put the carbon dioxide into. So, and a lot of reports I've seen is that the geologists are comfortable with a properly selected and managed site that carbon can be sequestered and kept away from the environment. But then if I look at carbon capture, let's say on a power station. So now, because I've got to break that amine bond and release the carbon, because I need compressors to get the carbon into a subsurface location, and I need to treat that carbon dioxide. I've got to get the water out of it, so I need dryers which consume energy. Those elements combine to provide a parasitic load on the power station. So you reduce the efficiency of the power station. You have to import more power or more gas to deliver a megawatt hour out of the power station. And if it's a combined cycle gas turbine, you'll have to import around 10% more hydrocarbon gas. If it's coal, it's around 20%. If it's single cycle, it's maybe 15%. So what I've done is I've put more onus on the gas suppliers to give me more gas. Now, with that comes more energy consumption and from the gas suppliers, and that more energy consumption means the gas suppliers are emitting more carbon dioxide, more sulfur dioxide, more NOx, more particulates, more volatile organic carbons, and it doesn't feel right. And what commercially driven company is going to bolt on this carbon capture plant that's going to need more capex, more opex? It's more complicated, so it needs more maintenance, which means more people exposed to hazardous equipment. And then the carbon capture thing, to me, it doesn't quite make sense. The only way it will make sense is if we deploy a carbon price that materially changes the economics. So we have to have something, I would guess, around 150, 200 pounds a ton of carbon to get commercial organizations to buy into this. And we're not there.
What are the potential environmental impacts of hydrogen production that are not widely discussed?
Supply chain emissions. Yeah. So if we're taking methane from a gas facility, and we're compressing it, treating it, taking it along a pipeline to a blue hydrogen facility, we've got leak paths all the way along that chain. And methane is a very, very potent greenhouse gas agent. It's something like, compared to carbon on a 100-year cycle, about 25 to 30 times more potent. And I struggle with the 100-year time frame, in that we have to get where we're getting by 2050. So why are we looking at the 100-year greenhouse gas warming potential? Why aren't we looking at the 20, 25 years, which is much more appropriate? Now, the CO2 difference to hydrogen is not now 1 to 30, it's 1 to 85. So methane leaks are a huge issue with, if we don't look after them, as well as just using the methane direct and gas power station without carbon capture. You can undo all the work of the carbon capture station by leakage along the supply chain.
Can you comment on the life cycle emissions of hydrogen production methods compared to other renewable energy sources?
Well, blue hydrogen, we can't capture all the carbon. So blue hydrogen still has a fairly significant carbon footprint. Green hydrogen is, apart from the process of manufacturing the wind turbines or the solar stations, is essentially carbon free. Yeah. And the electricity is green electricity. It's carbon free. So the electricity usage reverts back to something I've said a few times. We can get a lot more megawatts of heat out of electricity than we can with the same amount of megawatts of green hydrogen. So that obviously means less s- seabed footprint for turbines, or land footprint for turbines, or solar stations. So green electricity to me has a much better environmental footprint than um, than green hydrogen. Now, the pushback will probably come, and if we do mainly electrify the UK economy, we're going to have to double the amount of electricity that we're using today, and that's. Now, I've done the sums. That's what I get to. So then the concern is visual impact of pylons, perhaps, or as we're doing, we're taking some of the main transmission down the coast, where it is no visual impact. But there will be some downside with whatever way we go, and I guess that's a question for society. Are you prepared to put up with some inconvenience, whether it's visual or whatever, putting on a jumper when the weather gets cold, rather than sitting in the house at 22 degrees centigrade, eating less meat? Are we prepared to take some personal inconvenience? And I think we're going to have to, if we are to deliver on net zero.
How does the public perception of hydrogen compare with the scientific realities?
Well, I can only go in my own sample size on this, and my own sample size is see, when I go to the pub and have a chat with my friends who aren't like me, who aren't steeped in energy, who aren't reading reports daily on energy and energy efficiency, on hydrogen, carbon capture, etc. They are much more concerned about paying their bills on fuel poverty. I can't get them interested in hydrogen. It's just it's not on the radar compared to the immediate problems that they've got on a day-to-day basis and trying to make ends meet. Now, that leads me on to, there has to be an education program for the public to understand why we need to tackle global warming, what the consequences will be, and what we have to do as a society, and get buy-in, much more buy-in from the public. Yes, we have to do this. And at the moment, to me, that's a missing. And that, to me, that falls squarely on the government, whoever they are, to get these educational, public information, media things out, that the man in the street can see what the future that their grandchildren might be facing if we don't tackle problems now.
What are the key misconceptions about hydrogen as a low carbon fuel that you encounter in policy discussions?
Well, it's a low carbon fuel if it's green. So, but the misconception for me is again back to the cost, and there are better options out there. Make sure that you've analysed your options before putting your eggs in the low carbon hydrogen basket. And time again, I think that I see, and my numbers show, that there are better options out there for sectors like passenger cars than low carbon hydrogen. I'm also concerned about the lack of STEM trained politicians making decisions about hydrogen.
Mm.
I don't know how to get over that, but when I see, like, the Scottish Energy Minister, who has a background in TV media production, telling me that hydrogen is safe and that the 5 hydrogen community trial is fantastic, I just shake my head. I just shake my head.
And you're not a problem. There are people who don't have a clue about hydrogen, and they will get that seriously. How should hydrogen be positioned within the broader energy transition strategy?
Well, I can do no better than I think anyone that's in the hydrogen debate and looking at writings and reports. I can do no better than Michael Liebrich's hydrogen ladder in terms of what unavoidable uses to uneconomic uses, and I set it beautifully in that, and I generally concur with just about everything on that ladder.
What are your thoughts on the economic viability of green hydrogen compared to blue hydrogen and other low carbon technologies?
Well, green to blue really depends on the price of gas. Yeah. And what and that is, as we know, is a bit unpredictable. But looking at the projections for future gas prices, and electricity prices, green hydrogen, to me, for the foreseeable future, maybe the next 10, 15 years, is going to be cheaper than green. That's what I think the reality of the situation is. And I've said before that blue hydrogen, because it's made from natural gas, is going to be more expensive than the natural gas it's made from, and green electricity, so green hydrogen will be more expensive than the green electricity it's made from. So those two aspects are pretty much barriers to a lot of the deployment of hydrogen in various sectors. So the sectors that we need to deploy hydrogen in are those that are hard to abate. Those that, well, I guess my hierarchy, which is energy efficiency first, use less energy. Now, hydrogen just breaks that immediately. Yeah. Secondly, electrification, where electrification is shown to be a more attractive commercial and technically available solution. And thirdly, use low carbon fuels like hydrogen derivatives, biofuels, where electrification will be either not technically feasible or not commercially attractive. So that, and it's that tier 3 or the sea level ones that I think hydrogen should be used, and that plays back into Michael Liebrich's ladder, which shows the kind of unavoidable to uneconomic. I'm not sure it quite answers your question there.
Broadly, definitely. What lessons can be learned from international hydrogen projects and initiatives that the UK can apply?
Well, I'm going to kind of answer this negatively, in that because Germany, South Korea, and Japan are doing things, the UK shouldn't feel it's missing out on something. And the UK should look at its energy needs within its sphere, within its system. Not think I'm getting left behind because Germany are doing this. Again, evidence-led. And I think I scratch my head about a lot of the stuff that Germany seem to be promoting as a future low carbon fuel.
I'm very anxious to hear your opinion on this one. What are the most promising areas for future research and development in hydrogen technologies?
Well, I would green steel, I think, is key, and steel, I think it's around 9% of global carbon emissions. So that's a huge target. But just a little word there. Steel in the UK is only 2% of UK emissions, so it's not the big target that, say, Germany might have for green steel. I would see aviation, not, as I explained earlier, not necessarily as hydrogen as a liquid or a gas, but as a hydrogen derivative. some form of sustainable aviation fuel, accepting that that's going to be very expensive, but that might be the price of flying. The price of flying goes up if we want to make it carbon free. So long distance aviation, long haul aviation, and shipping, transocean shipping. We can't have batteries big enough to do that. So we're now looking at alternative fuels. And I guess my inkling is, well, biofuels and methanol. I used to work with ammonia in my petrochem days, and ammonia is a pig of a thing. It's terrifying. It terrifies me more than hydrogen ever would in terms of if we do get a leakage. Hydrogen's not toxic. This stuff is completely poisonous. So we do ship hydrogen around the world, but we don't fuel the engines. Sorry, ammonia around the world. We don't fuel the engines with hydrogen. Putting hydrogen into, ammonia. Putting ammonia into an engine room, well, firstly, the whole system to me is it so feels wrong from a safety viewpoint. So yes, shipping, aviation, steel, and of course the current uses of grey hydrogen. So that's in hydrotreating, in fertilizers, in conditioning oil and gas. We need to get those highly polluting current uses of hydrogen over to low carbon hydrogen.
Tom, thank you very much for being my guest today. This was really, really good lesson on hydrogen.
Thank you for having me. It's a pleasure.